Hi everyone, this is Jen with MathGenius, and today we're going to be going over some properties of limits and some examples as well. So first off, I just want to note that the limits of the functions that I've written here, denoted by f and g, must be finite. So they can't be going towards infinity or negative infinity, or these properties won't apply. So number one, I have the limit of a constant times a function is the same as the constant times the limit of the function. And I have the limit of the sum of two functions is equal to the limit of the first function plus the limit of the second function. Number three, I have the limit of one function times another function is equal to the limit of the first function times the limit of the second function. Number four, I have the limit of one function divided by another function is equal to the limit of the first function divided by the limit of the second function, given that the limit of the second function is not equal to 0. So we'll go over some more examples of that kind of limits, but in another video. And number five, the limit of a constant is just always a constant. So I think that these are mostly very straightforward, and as long as you practice some, I think it'll be really easy to understand it. So number one example that I'm going to use is the limit as x approaches 2 of 5x squared minus 3x plus 1. So I'm just going to show it step by step so that you understand how this exactly works. So I'm not going to skip any steps. So first of all, what I'm going to do is I can separate these because it's just adding and subtracting a couple functions. So I can write limit as x approaches 2 of 5x squared minus the limit as x approaches 2 of 3x plus the limit as x approaches 2 of 1. And so now I'm going to use my first property and take out the constants that are being multiplied to the function. So I have 5 times the limit as x approaches 2 of x squared minus 3, limit as x approaches 2 of x, and lastly, limit as x approaches 2 of just 1. So now if I apply my limits, I have 5 times, and here I'm going to get 4 minus 3, and the limit of x as x approaches 2 is just 2, and the limit of a constant is just always a constant, so that's plus 1. So then I have 20 minus 6 plus 1, which is just equal to 15. Okay, so that's showing my first two properties, which is taking out a constant and adding and subtracting different functions within a given limit. Okay, and so the second example that I'm going to go over is going to be with multiplication. So I have limit as x approaches 0 of x times cosine of 2x, and that is equal to limit as x approaches 0 of x times the limit as x approaches 0 of cosine of 2x. So now if I plug in x into my limit, I'm going to get 0, because for my graph x, as x approaches 0 from the right and left hand side, I'm going to get that L is equal to 0. And for the second limit, I have limit as x approaches 0 of cosine of 2x. Now cosine of 0, if I plug in 0, is just 1. So I get 1. And 0 times anything, as we all know, is just 0. So the answer to this limit is just 0. And so for my next example, I have limit as x approaches 3 of x squared minus 9 over x minus 3. So your initial reaction might be to first plug in the 3 into both the top and bottom, but you'll notice that you get 0 on the bottom, which, well, you get 0 on the top, but that's not really relevant because 0 on the bottom means that it's undefined, and that's not what we want. But we also notice that we can actually factor x squared minus 9, and if I factor that, I get x plus 3, x minus 3 over x minus 3, right? So I can just cancel these two because they're a common multiple. So I have limit as x approaches 3 of just x plus 3, which is the same as limit as x approaches 3 of x plus limit as x approaches 3 of 3. So we know that that's going to be 3 plus plus, and limit of a constant is just a constant 3. So the limit of this function, x squared minus 9 over x minus 3, is just 6. Okay, and lastly, I have the limit as x approaches 1 of x squared minus 1 over x squared minus 1. So once again, if I just plug in 1 into my x's, I get 0 on the bottom and on the top as well. And since I have 0 on the bottom, that makes it undefined, but that's not what I want, and I can actually see that x squared minus 1 over x squared minus 1 is just equal to 1 because they cancel out. And like I said, the limit of any constant is just the constant itself.